So now, if my screen starts showing, just do let me know, because I just like to see if my screen is visible or not. So just see.
Yes, sir,
Yes,
it
sir,
is
it is
visible.
visible. Okay, now, okay. So today's session is more about this random forest and decision tree. So there are two algorithms which are there inside this decision tree and random forest. Okay. Before I give you some idea about this decision tree or random forest, both can be used as a regressor as well as classifier. So when you say regressor means when you are predicting some continuous value. For example, what would be the the sales in some months, let's say in December, January, right? So you are coming up with some kind of a continuous value, right? But when I say whether you have a COVID or not, that is kind of a binary, right? Binary decisions or binary classification problem. Okay, so random forest and decision tree will see in terms of a classifier, because majority of the time this decision tree works well for this classification problem. Okay, so we will try to see how this decision tree and random forest works with examples, and also we'll see some in a descriptive manner that how this algorithms typically works. I'll try to show you a few codes, and I'll walk you through the different the descriptive the methods, and also some of the you can say the in-depth analysis of this random forest and decision tree. Okay, so obviously we'll try to cover these concepts. I mean, just a basic of it, because in summer learning, as I already told you, we'll cover in coming classes. But we'll try to focus more on decision tree and random forest, a few concepts of bagging and boosting as well, and obviously the coding part is very much important. So I'll show you this coding as well, that how you can apply this decision tree and random forest together, and we'll see that how if you're applying decision tree and random forest together to the same data set, what sort of you can say the kind of changes you see, the kind of predictions you see in the final outcome, that is more important to see. Okay, so when you say a decision tree, the something which comes in your mind is related with some tree. But if you are from a coding background, maybe C and Java, right? So you might have heard of some syntax called if else and then loop, right? So decision tree is nothing but it's more of the if else and then, it's more of a nested loop kind of a thing. So once you take some decisions, for example whether you want to go on holiday or not, that could be decided by your the financial health, right? If you have a money, right, and if you have a time, then only you can go on holiday, right? So it's like if and else kind of stuff, that if you have certain amount, then only you can go on a holiday, and if you have some time, right? So that depend on the different branches of the features, right? So decision tree works on those features, that how you come up with the decisions based on certain features, right? So I'm talking in terms of these features, because that is more important, because in your data set there will be multiple features, and those features gonna decide you the final outcome, right? So that comes under this decision tree. Okay, so how you just visualize it when it comes to decision tree. For example, if you have some friends and they want to visit, there are two places they want to visit this summer, right? So someone saying in your group that I just want to visit this Poland, or someone saying the Iceland, right? So how you gonna come up with some kind of a solutions that okay, you can just incorporate both the ideas of both I mean the group of students and the group of your friends, right? So I mean that is the something we typically take decisions, and there are multiple decisions which this different companies take day to day life, right? So I mean there are different business cases based on this decision tree only. Okay, so I mean for example, if we want to give loan and to some customers, okay, so you are running, let's say ICICI Bank, and you have, let's say, crores of the users, right? So customers, and you just want to give loan, and so obviously at that time you require some kind of features, and based on those features you just branch it out, For example, if and else, for example, if he has some salary of let's say 30,000, and whether he will default or not, then only you can give loan, right? So there are a different way to further decide the outcome using this decision tree. Okay, so I mean, your one friend is saying, okay, so I just want to visit Poland, and friend B is saying, Iceland. So, I mean, this is something. I mean, it's a problematic for you. So, how are you gonna decide it, right? So, for example, there are different factors. Or here, if I say factors, it's more aligned toward the features. Just think in terms of a data set where you have a different input features, and your target outcome is whether you should visit Poland or Iceland, right? So this is a two outcome. This is a binary outcome that you wanted to predict based on your based on your friends, the features. So obviously, if you have a friends, and then if they have a budget, right, and the time, so maybe some friends have a less than 15K budgets. Okay, so they might not be able to visit Poland, right? So, and possibly if they have a time, so there are two factors which are coming always, right? So when you are deciding any this decision tree or random forest, so you have to play with different features. Okay, so obviously the features, how you are picking up the features, they're gonna decide you the final outcome, right? So here the budget and time is the two features, and the outcome is whether you want to visit that place or not. So this is a binary case. Okay, so this is something related with if and else. If you have a budget of 15K, more than 15K, and you have, let's say, a 15 days time, okay, more than 2 weeks time, then only you can visit, let's say, Iceland. If you have a less than 15K and 1 week's time, then obviously you're gonna visit Poland or something, or even you will not. Okay, so depending on this data set, I'm just trying to show you that how you take decisions based on this budget and time. So the similar kind of stuff can be replicated with different use cases, different business cases. Okay, so I mean, so this is just a snapshot that how you take decisions based on decision tree. Okay, so I mean, let me give you that why you are coming up with decision tree, because there are different algorithms already available. So in the last class, or maybe last to last class, you might have exposed to this logistic regression. Okay, so logistic regression is what? It is a more of a classifier where if you have some binary classification problem, you can apply. And also the same concept and the similar kind of stuff you can apply with the decision tree as well. Okay, because if you are solving some classification problem, then you have a bunch of you can say a bucket of classifier algorithms available with you, but how you gonna select it? That is the something that I just want to give you, that you cannot use same weapons for each and every target, right? So you must sharpen your weapons for a specific target. So that is where decision tree works for a specific the business case, not for all the cases. Even if this is a one of the finest classifier, you cannot use it. If you want to use logistic regression, you cannot use this decision tree at the same time. Decision tree has some specific advantage because it uses this if then and else decision making, right? So it's a more of a this kind of a thing. If you see your data set, and where you see there are conditions where if you apply this if else and then, your problem could be solved, then you just go with this decision tree. Okay, so I mean, decision tree, if you see the third part here, so this decision tree are used in business community to work on customer segmentation type problem. For example, let's say you people are from MBA, and obviously you just you typically go with this kind of a problem, right? Customer segmentation. So you I mean every day you might have seen this kind of a problem coming up in a different format, that how you just segregate the customers, how you segment the customers. So there are 4 P's of marketing which I can recall from my MBA days. So maybe place, person, this kind of a thing. There are 4 P's and there are 7 C's or something, right? So how you just segment your customers. So obviously it's some sort of a decision making. So if and else is there, right? So you just segment your customers. For example, if someone has let's say the salary is huge, I mean someone is getting paid a huge salary, someone education is much higher, right? Someone is from tier 1 city or tier 2 city. So you just try to segment those customers, and based on those segmentation you try to give some kind of offers, some kind of, in terms of marketing, you just send some kind of SMS, but you do not send entire SMS to entire populations, because once you are sending the same set of the SMS or same set of marketing, it will not work, because what you have to first classify it, first you have to segment it, and then only you can send this SMS, right? This is more of a marketing, right? So these things which comes in the I mean will come when you apply this decision tree. Okay, so for example, as I have given you one example, let's say if you are running some SMS campaign, right? So you cannot send each and every SMS to entire population. So you have to pick some sort of the customer segmentation thing, and then you just decide to which customers you want to give this SMS to, which template you wanna send it to, right? So that is the something which is being decided by this kind of a thing, that is called a decision tree. And there are also this k-means clustering is applied, but if your data is not labeled, in that case you just go with this customer segmentation using this k-means, that is more of a clustering, right? Otherwise, if your data is labeled enough, data has some target value, so in that case you just go with this decision tree, because data is labeled enough. And the beauty of this decision tree is it can handle both numerical data as well as your this categorical one. So this is the beauty of this decision tree. Okay, so I mean one of the features which I say is for this decision tree is obviously it is used for classification. If you see on the right side, so if you plot this is called a linear distributions, because this is your line separating, right? So separation of a line that divides the two classes. So this is linear distribution. So your data is somehow concentrated on one of the one of the axis, or you can say concentrated on one of the areas, right? So majority of your data. But if your data has a non-linear distribution, if you see this one, right? So for example, on the right side, your data has a non-linear distribution. So let me just tell you that what is red and blue. So these are the two classes. Let's say someone you have given a loan, and this is a loan data, right? So you have plotted, and you see red one is the people who haven't returned the loan, or something like that. They are the defaulters, right? So defaulters and non-defaulters data is there. Okay, let's say this is the 500 customers, and based on their the historical transactions, so you are able to plot it out that whether someone will default or not. So this is your entire axis. So this is called non-linear distributions, because there is an if you just put a straight line here, so there will be a few misclassifications, because these are non-defaulters and these are defaulters. So if I just draw a line like this, so there will be some kind of a misclassification. Okay, so but this is a non-linear distribution. So you see, had it been a linearity, so majority of your red point would have been on the right side, right? So on this side. But here there is a mix of there is a defaulters and non-defaulters on the same line, right? So in the same distributions they are there. So these are the non-linear distributions. So how you gonna solve this problem? This is one of the business case that you have been given, and by looking at the data, by looking at the visualizations, and by looking at the EDA exploratory data analysis, you have seen that the data which are scattered, the data points and the labels which are scattered, the manner is that they are non-linear. So how are you going to solve it, right? So that is the critical problem, right? So to solve this, you have to come up with this this decision tree, that and I will be explaining you that how you're going to use it, right? So there are different cases where you can use a classification problem, but I'm talking specific to this decision tree and random forest. For example, if you have some, obviously in the last class, you have seen this tumor classification, so you can come up with this logistic regression as well. But if your data is non-linear, so how you gonna know that your data is non-linear? Because there are no specific, visualizations techniques available right now, so that you can see your data, how your data is, distributed, because it's a multi-dimensionals. Because had it been, let's say you have a 20 features, so it will be 20 dimensional data, and you cannot see that how your data is segregated, how your labels are segregated, right? Whether it follows linearity or non-linearity, that is the problem. So that is why you have to take help of all the classification algorithms, and you have to see their accuracy. Because if their accuracy is somehow similar, then you just take one of them, right? So for example, in the credit card transaction, so whether a credit card transaction is fraudulent or legitimate, right? So that is the something, the two binary classification problem, and protein structures in this medical domain, where they'll just like to know that they just classify it whether it's a beta sheet or random coil or something. So these all comes under classification problem. Okay, let's say you have a text data, and now you just want to apply this decision to your random forest. Okay, so the news story could be easily be classified. For example, if a new news story comes, and you just want to classify it whether it belongs to entertainment or sports, right? So if you have a model already trained on, right, so if a new news comes, and you can easily segregate, and you can easily put it in that bucket that it's related to sports, right? So there are the different use cases, and the business cases which are available, and that can be solved through this machine learning. Obviously they are the traditional machine learning, but the beauty of it is that that how you are applying it. It's not like the every single classification algorithm or the business problem can be solved through this decision tree or random forest, but you need to understand the crux of it, that where and why I'm applying this decision tree or random forest, that you must be sure of. So in today's class, I'll give you a clue that where you can apply this decision tree or random forest, but not each and every classification problem. If you see each and every classification problem and you jump on to apply every single this classification, that doesn't work like that. Okay, so for example, this is one example, and just I'm giving you for example, this is your training data set. Just understand this. That is why I'm just using this data set. So this is your training data set. For example, attribute 1, 2, and 3. There are 3 attributes, and third one is a class. Don't get confused. This is a target variable, and these are the features. So sometimes it is called a features and target. Sometimes you call it a attributes and class. So class, target, labels. These are the something which are being used, and this is a supervised one. So, and this is a test class. You don't know if attribute is no, small, and 55k. So what would be the class of this, right? So this is something which I'm just trying to explain, right? So in each and every classification problem or any machine learning algorithms, you'll have something called a training data set. Because the humans, how you get trained? You get trained through your parents, your family, friends, office, and public places. You go each and every places, and you get some kind of a training, right? So some kind of external environment, and then you try to learn things. The same way machine learning works. So they just see what is in the training data set, they understand the hidden pattern in it, and they try to store it, right? So whenever some unseen data comes, so unseen is nothing but this is a test data. Okay, this is a test data that is unseen to the model, right? So how this will work on unseen data is work of machine learning, because they have a trained data, right? This is a training data is there inside their memory, right? Based on these models, once you apply, let's say on this training data, you are applying decision tree, and you have saved the result, and then you are passing this test data to it, right? So test data is gonna test the training data, that how much your model has learned, the hidden pattern inside it, that is the more important, right? This is the crux of machine learning, that how it typically comes up with this unseen data, right? The test data or unseen data is the same thing, right? So The learning algorithm, let's say here is the decision tree. Your model is going to learn from the training data, and you are exposing your model to test data, right? So this is how your classification algorithm works, right? So now let's say, this is one example. Let's say this is a refund. One of the, let's say, maybe some banking data is there. Let's say a refund, he hasn't refund their marital status, taxable income. They're gonna cheat or not, right? So maybe this is kind of a defaulters, you can say, and they have given some kind of a loan. Let's say, assume it, right? So a person, their marital, let's say, refund, he hasn't refunded it, okay, no, and marital status is this one, and he is, let's say, a married or something, so he will not cheat, right, or something. If their taxable income is less than 80, right, so he will not gonna cheat. If their taxable income is more than 80, they're gonna cheat or something. So this is how you take decisions. So decision tree works based on the features. If you see the features, there is a splitting up of the features, that is attributes. So here the refund is one of the features. This is a categorical one. This one is categorical, but taxable income is continuous. So if you see in the decision tree, and if you see the data set. So let's say I have given you a data set, or maybe in an organization where you work, they have given you some data set, flat files, right? So first you just see that how their features are, whether they are categorical or continuous. That is the first thing that you have to notice. And is there any target variable or not, whether your data is supervised or not. If it is supervised, just try to segregate it, whether it's a this features and target together, and just see their the type of data they have used, whether it's a categorical or continuous, okay. And then you come up with this kind of a decision tree. So how inside the model, right, so how they train it. So this is the way decision tree train their training data, right? They just split it up. But how they split? They are splitting based on these features, based on this attribute. Refund is one attribute, marital status is one attribute, and taxable income is one attribute. So they are branching it out based on these features, and they are coming up with this target variable, whether they're gonna cheat or not, right? So this is how your decision tree works. And I'll also tell you that how random forest work later on, but decision tree works the same way. It's more of a if and else loop only. It's nothing, okay. So this is how this your you can say this decision tree works. So this is just an extension of it, okay. So for example, if you see this one, so as I already explained you that this attribute. So this is the training data set given to the model, and you are seeing just learn it through decision tree. So your model, the model which are once trained, this model is learning decision tree through this training data set, okay. So you have passed this training data set to the model, and you have told your computers to train this model using decision tree, and just save it somewhere. You call it a PKL file or model, right? So your model is now saved, and they have learned it through decision tree. So this data set is learned through this decision tree only, not through logistic regression. So, and once you pass this unseen data to this model, so they will give you this class predictions, okay. This is how it works, okay. If you are saying your model to learn it through logistic regression and save your model here, and you are passing this test data, the result would be different from decision tree and random forest, okay. Because each and every algorithm, their learning capability, their learning the hidden pattern inside the training data set is totally different. Each and every algorithms has a different capability, different mathematical, you can say, computation, mathematical adjustment is there. So they learn it through different way, right? For example, if I tell you to learn, for example, if you are sitting in physics class, chemistry class, or maybe in history class, the same problem could be taught differently, right? So the same way it happening, the algorithm is different, the solution of a problem is the same, but their accuracy, their decisions may be different, because they learn the pattern differently, okay. So the same way, the humans approach the problem differently. For example, if you give me, if I give a problem, same problem to the entire class, maybe there will be some unique solutions. Okay, so the same way it works. This machine learning algorithms works same way, because they also come up with different solutions because they see hidden patterns in different manner, and they solve through different mechanism, right? So the previously, because now you want to predict, so this is a test data, because refund is this their marital status, and they will cheat or not. So this is a test data that you are passing. So you will start from the root. This is the refund. Okay. So no marital status, married, so they will cheat or not. So this is how you have to work. This is your test data. If you see, this is a test data. Model is already developed. Your model. This is a training data which already developed. Now you have to pass this test data only, and then you see that whether cheat is yes or no, right? So if you see, this is a refund. Just try to see that how your this decision tree typically works. So refund is first root. So he is he will not refund. Marital status is married, right? So he will not cheat, right? So this is how it is working. So if you are passing this test data, your model is gonna give no to answer, right? So it's a no, right? It's like a zero, right? So this is how it typically works. And now this is very much interesting, because I just wanted to draw your attention here, right? So when I see, I was just focusing on this non-linearity, right? So non-linear behavior, that is more important, right? So for example, if you see in real life, there is nothing linear, right? So there are also something which you face is non-linear, because linear is something which human can understand, that if you are increasing, let's say, number of product, maybe sales will increase. If you are increasing your advertisement budget, maybe your sales will increase, maybe revenue is gonna increase, right? So this is a linear behavior. If you are increasing one, otherwise decrease or increase. That is the two way, right? So that is a linear. But there is a non-linear things happening in your life, or maybe in the business case, because if you are increasing something, other will decrease or increase, you don't know, right? So maybe sometime it increases and decreases, right? So you don't have a clue of that how it is happening, right? So for example, in a loan case, and a bank has a problem that to whom they just lend money to, right? So they just want to create some kind of a machine learning model. They approached you to they have some, let's say, 10 years of a data, and they approached you as a consultant that okay, so just solve this problem, because I'm facing that if I'm lending money to XYZ person, just they are taking money and getting away with, right? So how you gonna solve it, because your data is huge, and now you have to find the patterns inside the data, and they have, let's say, 10, maybe 12 to 15 features, and they have some labels that these persons have cheated and these persons haven't, right? So obviously the data would be non-linear in nature, right? Because it's a huge data. But there is an opportunity when you have a huge data set. There is an opportunity, because the patterns, the hidden patterns inside the data can easily be picked up by the machine learning model. They can easily understand that if there are some this hidden patterns, so they easily just catch those hidden patterns. Okay. So let's say here there are a few this, let's say, 1A and B. Maybe it's a defaulter and non-defaulter, let's say, and these are some data points. Let's say these are 10 lakhs of data, this dot 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 inside this, and this is also 10 lakhs of data. Let's say you have a 20 lakhs of customers data of ICICI Bank, let's say. Okay. And now you have to decide that which algorithm to be used. If you see this one, they are learning the non-linear behavior. Just see this, they are capturing the non-linearity. Why? Because there is a if and else loop. If, let's say, the threshold is 1.2, and let's say their credit score is 3.2, then he will not in default, they will fall under B, right? So this is something you can interpret, right? So the decision tree has a beauty of capturing the non-linear behavior. Okay. But if you go with this logistic regression, what they do, they typically go with like a straight line or S curve. They do not have a flexibility of capturing the non-linear behavior in a data set. So they do not learn non-linearity in the data set. That is the critical problem of logistic regression. But when it comes to decision tree, they have a sharp memory to learn this non-linearity. That is why if you see the accuracy part of this tree-based algorithms is much higher. Why? Because they incorporate this non-linear decision surfaces inside it. Okay, so non-linear decision surfaces, they can easily understand it. That is why majority of the time you will see the bagging boosting kind of algorithm, the tree-based algorithms, you'll see their accuracy is much higher in majority of the cases. Okay, so this is the something which we have to remember, that if I ask you, or maybe in the interview they ask you that why you are coming up with decision tree, why not logistic regression or support vector machine, the you have to say that the decision tree can learn the non-linear decision surfaces also, right? So obviously how decision tree is created. So I mean there are a two way, and when you are creating a decision tree, I mean, and how they learn this training data set, so that is a more important, right? So there are two approach. One is tree building phase, that how you are deciding a tree to be grown, right? And second one is a tree pruning phase, that which all nodes you don't want. It's a more of a pruning, it's more of a cutting out the branches of a tree, right? So I mean, if I say this, a kind of a tree building phase, so it's a more of a partitioning things, and I mean the examples in each partition belong to one class. So you try to partition it through this if and else, and you just just you end up this partitioning once you get this class label, right? And tree pruning is like, for example, you want some features or not, and you just try to remove dependency, a kind of a noise that you just don't want to be included in your training data set. So, I mean, these are the two way out to train your decision tree model. So that is a more important, because the logic behind this, the rationale behind this is that there are two phase, and you create this training data set, and how your decision tree models learns, and you'll see that how this pruning and how you just decide it, that is more important. Okay, so and there is also something called stopping criteria. So I'll show you through one of the examples, then you will understand that what these terms mean, because these are some jargons, but you just try to understand, because in interview they ask you this is stopping criteria, that where you're gonna stop a tree, because once you are growing a tree, they're gonna grow it like anyway, right? So I mean you have to stop it somewhere. You cannot grow a tree like like a mango tree or maybe people tree or something, right? So I mean you have to decide that where you want to stop through the features. Once you get the labels, target labels, you have to stop it, right? So I'll show you through one of the examples that how you use this stopping criteria, and there is something called information gain, entropy, and everything in decision tree. So I will be touching upon that how you use these terms to take some decisions, that how you just want some kind of a hyperparameters. So which hyperparameter to pick and which hyperparameter to skip, right? So let me show you a few examples also. So I mean, why you are using, and why we should use this decision tree model, why not other algorithms. So when it comes to this decision tree or tree based model, I'll say to be more specific, right? So it's more faster compared to classification model, because why it is faster, because it's a more based on this if else and then loop, right? So that way it's much more faster. Okay, and accuracy is higher, a bit higher, because they incorporate this non-linear decision surfaces also. They learn these non-linear decision surfaces also. That is why their accuracy is a bit higher to other models, and obviously it's a easy to understand, and there is one term called interpretable AI. So your decision tree model are self-interpretable, because they uses this if and else and then, because also a human can understand. So that is why the term interpretable machine learning is also there. So this is a decision tree is opaque model. You can see what is happening inside the training data set, that how they are taking the decisions to train the model, right? So this is a more aligned toward this interpretability of the model. So maybe in interview you might be asked that what is interpretable in terms of machine learning. So how you going to interpret it, because the output, the you can say the responses or the classification, the output which are coming from decision tree or any machine learning algorithm, whether you are able to explain it to your client or not, the end user, that is more important. Because if I, let's say if I have been asked to come up with some kind of classification algorithm, and I have used some, let's say, high level of algorithms, and I tell my manager that okay, so and this is the output, why you want interpretability of the model, so they will, they will just discard it, right? So because they do not understand that how I have solved this problem, right? So interpretability is more important, because where if you are able to explain that the all features are important and contributing towards this response, the output which are generating from my model, and the reason is this, so that will be your transparent model. Okay, so that is why decision tree makes uh, it makes more important to the model because of these kind of features, right? So and this confusion matrix in the last class you have seen, but there is a separate slide. So in the coming class I'll show you that what is confusion matrix, and also today I'll touch upon this predicted and actual value, that how you're gonna read it, because it's very important to understand this confusion matrix, because the output which are coming will come in form of confusion matrix only, because it's more confusing to call it a confusion matrix, right? So how you gonna interpret this confusion matrix is more important. So today I'll also explain a few things about this confusion matrix, that how you should read it, right? So how you gonna just split the node, I mean, that is the something important, because when you see, when you have a data set and I tell you to just split the node is nothing but it's a features. Like for example, in a loan case you have a 10 features, whether you want to split the node based on age, based on location, based on eligibility, based on education, based on demography, that is the splitting of a node, right? So how you gonna decide it, and how decision tree typically decides that which nodes to be splitted, that is more important. So there are two criteria. One is entropy and another one is information gain. So you might have you might have a familiarity with this entropy and information gain, maybe in a physics class, maybe in class 10th or 12th, but these are aligned with that topic only, but it's totally different, right? So I mean, how you gonna decide that how to split the node? So these are the some mathematical way, and just put your attention here, so that we just see that how this entropy or information gain works, and to split the node. Okay, so let me just draw your attention here. So how you just define this entropy, right? So it's a randomness on measuring the disorder of the information being processed in the machine learning. So and how much randomness and how much disorder is there inside your data set, that is the something which machine learning try to understand it. Because when you pass entire training data set to any model, any machine learning model, so what they typically do, so they just try to find out the hidden pattern, they learn it, and then they save it in a model, right? So this is how it works. So also they see that how much randomness is there, because randomness is more of some kind of error, some kind of disorder in the training data set. Okay, so you can say, in other words, that entropy is the machine learning metrics that measure the unpredictability or impurity in the system. So how much unpredictability is there inside your training data set is more, you can define it as an entropy, right? So and entropy will be highest if segment has both class in nearly equal proportion. So let's say this is a data set, this is a, segment of probability of 1 and probability of 2. Let's say this is defaulter and non-defaulter class. Okay, and they have, let's say we have a different, let's say 13 instances or 13 the customers, their data is there. They're going to default or not, this is their probability and their entropy calculation through this formula only. Okay, and why you are coming up with this entropy is obviously that we just want to split the node, because we just want some kind of if else loop to be applied. That is why you are looking for this entropy, calculation of entropy, and this, whether your segment is pure or impure. So don't look at like a maths, just try to understand the few things, that how if your entropy is lesser, than whether you should go with this x node or y node. That is more important. Okay, so let's say then there is a second term called information gain. So I mean, if you go with the formula, entropy before splitting and entropy after splitting, so this is just kind of information, yet how much informations we are gaining from the training data set. That is something which we are calculating, right? So I mean, why we are calculating this information gain and entropy? So why you're using? Because the features and attributes that render maximum information about the class. Okay, so information gain is more important, and we just want to know that the which the class has more information. For example, if let's say a company wants to split the node based on salary, then they will have a more informations, because that is something, a solid criteria or a solid, you can base a solid features to split the node. Because so the how you gonna calculate it, so this comes from this information gain. But let's say this is a logical mind which you are applying. But let's say your data set is huge, features are huge, then how you gonna decide? So these are some matrices, you can say the mathematical way to come up with the idea that which node to be splitted, right? So this is how this information gain and this entropy works. And I mean, you'll see that through the one of the examples. So this is one example. So if you see this example, let's say you have been given this example. This is historical data of sales data from an online websites, let's say. So let's say you are running an e-commerce company, and you have this data from your historical data, let's say 2 years back. So I mean, so gender is M, their income is higher. So they have, but they haven't ordered the product, right? Just see, this is the combination. So this is your target variable, class, label, and this is your features. Gender and income band is 2 features. This is the input. Just think in terms of maths. Gender and income band is input, and this is output. But in terms of machine learning is a features and target. So when you are solving any classification problem, just try to understand, you just call it a feature and target only. Okay, so gender and income band is 2 features. Let's say there is one female and having a low income band, but they have ordered the product, right? So, and there are also a male having a low income, they haven't ordered the product. So you'll see there is a randomness, and there is a non-linearity. There is a non-linear thing, right? So let's say if I'm just targeting a male high in income, they haven't ordered the product, right? Higher, they haven't. So there is a one pattern, but there is also a pattern when male and high, they have ordered the product, right? So there is some kind of a linear and non-linearity and linearity together. So that is why, I mean, by looking at the data, you must have an understanding that decision tree or tree based algorithm can work well, right? So how you gonna apply this decision tree here on this data set, right? So, and let's say this is your training data set. So we have a 15 instances, 15 observations, or 15 you can say the client's data you have, that is historical data, and whether they have purchased some product from your e-commerce site or not, and you have a gender data and their income was there, right? And you just want to understand their behavior, and also you just want to predict it, that if some males comes and if they have a lower higher income band, which product to be given the recommendation. So you just want to understand, and you just want to apply it to your website, that how you can reach the user interface. And so that you can appeal more customers and you can increase your revenue. That is your end goal, right? So let's say this is your unseen data. Two customers which are coming who are male and female, and their income is higher and lower. Now you want to predict whether they will order few products from your e-commerce portal or not. That you just want to decide, and you have this training data, right? This is your training data. So on this training data, you will apply decision tree. You will save the results of a model. You will train this ML model, and you will pass this unseen data. Unseen, you can say the customer's data, and you'll see that what your model predict. So now you'll see that in a real sense that how it will predict if gender is female and their income is low, whether they're gonna buy it or not. So through this decision tree, let's see how you're gonna solve it, right? So let's say overall 15 instances or 15 training data or 15 clients data was there. Overall, you'll see this is overall, and 10 say no, they haven't purchased, 5 purchased it. Okay, so the probability of no is 66% and probability of yes is 33%. Okay, if you see this biasness of a data, biasness of a training data, you'll see majority of the data belongs to one class, that is a no class, and there are a few bunch of people who belong to the yes class, right? So but if you see this entire data is skewed towards one class, that is a no. Majority of people saying no and don't buy it from your e-commerce portal, but your worry is to how to convert it at least from 66 to 50% yes, right? That is your struggle, right? So how you gonna convert it, right? So I mean, if you are splitting it through gender, because there are two features, if you see there are two features, one is gender and income band. So through the information gain in entropy, we are trying to split the node, right? So now our target is to split the node first, and then you'll decide the this prediction. So the gender is, let's say there are 9 male and 9 female, let's say here. So 9 male say, let's say 7 say no and 2 say yes. So the probability of no and yes is 77 and 22, let's say approx. And let's say there are 9 female were there. So out of 9 female, 3 said no, 3 said yes. So there are chances of 50-50%. So the tree representation of historical product sales from a website. So if you are splitting based on gender, you see this kind of a distribution of classes. So okay, so yes and no and yes and no. Okay, but if you just further branch it out, for example gender, so you have a gender, now you are further branching based on this segregated the income based. Let's say there are 7 people whose income was higher and there are 2 people whose income was low. Out of 6 haven't purchased and 1 purchased. So the no classes, the purchase of nothing purchasing from the website is 85. The people having the higher money are not buying product from your e-commerce site, right? So this is how you can interpret. But the females which have a higher you can say a percentage, so 3 haven't bought and 0 yes, I mean obviously maybe they haven't, so 0 no and 3 yes. Okay, so I mean the females whose income is low are buying your product. So why not to roll a product female centric, so that you can at least increase your product buying, right? So this is how you take decisions, right? So this is not a way to lose your customers. If male is not buying, why not to put a product related to female, right? So that you can catch attention of, right? So this is something a kind of a decision making through human way, that if and else, you're applying if and else. But if your data set is huge and now you just want to take decisions, you cannot go and read or write a code in the computer, right? But you have to take help of this machine learning algorithms. Okay, so now if you are splitting the node based on income, if you see, so let's say out of 100, 50 say yes and 50 say no, then low income 60 and high income 40 or something like that. And splitting based on gender, let's say now if you have a data is 100 people, right? So for the male and female, this is one way, right? So how you gonna split it? So that is a more important. Okay, So through the data, I'll try to calculate the entropy. So this is one entropy calculation. So if you are, segment 1 and segment 2, right? So in a segment 1, the entropy is 1, and segment 2, the entropy is 0.81. So this is just a segment, calculation of entropy. But the larger picture is here. So if you see this, you are splitting the node based on income. Let's say 100 customers were there. So 50 say yes, 50 say no. So the classes representation of buying and not buying is 50-50%. And based on the income, if you see 40 and 52%, that is much better. Also, if you see the income by, this is also a better. Okay. So entropy is 99, entropy is 98. Here entropy is 65, entropy is 0. Okay. So if you see the information gain for gender is 61, but information gain for income is, if you see this is a 14. So if you see, if I ask you to which model or which splitting techniques to be to be used, you have to see the higher information gain somehow, because the how much randomness your model is capturing, that is more important, because once your unseen data will come and test the testing model, then randomness will help you out to predict your unseen data. So if information gain is higher, then you have to take those models. So I'm just giving you an idea. Let's say that I give you this chart, okay, and I tell you to decide based on two features, income and gender, whether from your e-commerce portal people gonna buy product or not. So which node or which feature node you gonna take. So obviously the 61, that is the higher information gain. It means there are more randomness, your model is gonna capture it. So it's more of a non-linearity. I mean the non-linear decision surfaces. So out of 10, 6 non-linear decision surfaces your model gonna learn if you are splitting your model based on this gender, right? If you are splitting based on income, just see even less than 1.4, it's a 0%, you can say 0.1 or something like, okay. So I mean that is a not way, like it is not even understanding a single decision surfaces. Here it is understanding 6 decision surfaces. That is a non-linear behavior. That is why this decision tree comes into play if your data set is random and has non-linear behavior, right? So that is something which you have to understand, okay? So then comes something called overfitting. Okay, so when I say overfitting, and then there comes a term called you might have heard of this overfitting and underfitting. So let me just give you an idea that when I say overfitting, what does it mean? So overfitting means let's say you have a training data, and let's say I have given you a data set, or maybe let's say a company who is training some machine learning model, and so you have applied this decision tree only. So when it comes to overfitting, it means they are learning the entire training data, they are memorizing the entire training data. So they are not understanding what is the pattern inside the data, but they are just memorizing it. For example, if you are a student, there are few students in the class, they just memorize things. But what if I give you questions which are different than what you have memorized, right? So you're gonna overfit it, right? So these are the terms which are very much important in overfitting. So whenever you see overfitting, it means your model is memorizing the entire training data set. They are not learning a new concepts, a new hidden pattern, right? So that is problematic for you, because why? Because when unseen data is coming to your model, your training data will not face it. They will give a garbage result, they will give incorrect predictions. That is why you have to solve this overfitting problem, because overfitting means your model has just memorized things. They have nothing on new learning, right? So that is not a part of machine learning. Machine learning means that should be some intelligence, right? So overfitting is obviously accuracy in a training data, because it is entirely memorizing the training data. That is why there will be higher accuracy in training data. But when it comes to test data, that will fail, right? That is the problem. And in the overfitting generic patterns, if model is learning only the generic pattern, but they are not learning the specific pattern, right? So I mean, it's memorizing the entire data. That is the problem, which I'm just trying to make you understand, right? So in overfitted model, if you make some small changes in the training data, so there will be a significant higher changes in the final rules, because it's like a memorizing things. So once you are putting a small changes, the entire model, their output will be deflected, right? So to solve this, there are many ways to solve this, and how you just try to solve it, because in real scenario, the business cases, you'll see, you just uh, try to see this kind of overfitting, because model will overfit, and your predictions will have a no value, because it's just more of a memorizing the entire training data set. So I mean, before I go to a further slide, can you check, you all people, can you check your classroom portal and just see that there is a one coding that will reflect on now. Just see if that is there or not, coding decision tree and random forest, and do let me know that that is there or not. Then I'll proceed. Okay. So if you see, let me just, okay. Is my screen visible? Just confirm.
Yes, sir.
Yeah, just see, Deepti, this coding which I have said you in a classroom. Just see if that is available or not. Okay. So just see if that is available or not. Okay. So and that will be visible to a classroom. Okay. Decision tree and random forest. Okay. So coding or something that is written. So I'm just showing you that how you can apply this, right? So these are the
Yes,
basic.
sir.
Yeah.
Sir, this is on the classroom
Yeah,
portal.
just open it and try to, I mean, run it side by side, so that that can work. Okay. So I'm just, everyone just download it and just try to run it. Maybe even in a Google Colab will run, because dataset is somewhere in this URL. Okay. You don't need to upload it anyway. Okay. Dataset. So dataset is here. Okay. So how you gonna use this decision tree? Okay. So I'm just showing you a small example, and so that you understand that how decision tree can work, and also the random forest. But let me show you. Okay. So these are the some basic library that you require, and matplotlib, why you require, because there is some decision tree, the this, it will show you in terms of some graphs, if else. Okay. So that I have run, and the data set is here. So if I just click it, you'll see. Okay. And this third one. Okay. Just see. So this is just a small data set. So if you see, this employed is one feature, bank balance and one salary is a three feature, and defaulted is your target variable, class or label, right? So this is a supervised data set, because these are three input and this is your output. Defaulted is your output. So my data set is here in data set, and in X is input. I am passing all the input features to 3. This is also called a predictor attributes, and Y, that is your output, that is your class or target variable, is defaulted. Okay. So this is how I have passed in the model, and this is a training and testing, right? The similar way. For example, if I am saying a test, keep 20% of a data from the entire data set for testing, only 20, and give 80% for training the data. So you just give majority of a data, let's say maybe 80 to 85% data to learn the model, and 20% for testing it, because whether let's say someone is employed and their salary is something, and their this defaulted or not, something, whether it will default or not. So that will be dependent on unseen data. Let's say if you are keeping these two row as unseen to the model, then you're from the training data, once your data once your model is trained on the training data, then on test data you can save it, okay, the predict it, okay. And this is called a feature scaling, but here it is not required, but still I'm using it because in decision tree you don't require any kind of a feature scaling, right? So because it's if and else, you don't require it, but still I'm using it because in each and every algorithms which we have used, so just trying to follow it, but you don't require it feature scaling here, but let me use it, okay. And there is something called a decision tree because it will create some kind of a decision tree, and we are passing this decision tree classifier, okay. We are importing this tree model, and we are trying to model it. So this is a model, dt model 1, this is user defined, don't get confused. And this tree dot decision tree classifier, you are just training the model, this one, okay. So here, so we are just modeling it, and once it will model, it will show something like, I mean, it is running. So let me show you this screen. So this is already done. So once you run it, you'll see this will take some time, okay. So you'll see some branches like this, something like this. This is nothing but this is a decision tree. Based on nodes, they have decided that which node to be splitted based on information gain and entropy inside them. Once you run it, they do everything inside that. They calculate information gain, entropy, everything, and then they give you this decision tree, something like that, whether they will default or not, something like that, okay. So that is why it's more of a decision tree, right? And this is a predictions, okay, don't get confused with this prediction. So these are some confusion metrics, okay. So now these are the same thing, confusion metrics. So let me explain you this confusion metrics first because that is more important. So let's say you have let's say these are the number of let's say there are 2000 customers were there, and yes is I mean they will default, and no is they will not default, okay. So this is in actual data set that 18882 people in the actual data set, they haven't defaulted, and also your model has predicted that they will not default. It means it is good, right? In your training data set, 188 people were there, those who haven't defaulted, and your model is also saying they will not default, right? And the same goes with this, yes. 23 people were defaulted, and once you trained your model, when you passed it on, your model is also saying these 23 people will not default. But the problem is this 51 and 44. Why? Because actually in the data set, it was these are the people they haven't defaulted, but once you predicted they have defaulted. That is the critical problem, and the same goes with this 51, okay. So actually they have defaulted, but your model is saying they will not default. So you'll see this 51 is very much critical, because at least, I mean, you have to bring people in that they will commit crime, right? At least you have to find it out. The people who haven't committed any crime, if they are in a jail, that is a problem. But the people who have committed crime and they are not inside the jail, right? That is a more pain, right? So the same thing goes with here, okay. So once you run it, hope it has run, okay, the same output would have come. So if you run it, this is a testing, the same thing, nothing to explain. And this once you see this here, it will come, it may changes, okay. So 49 people is problematic for us because your model is predicted they will not, but actually they have default. That is the pain point. But once you apply this, also this is accuracy, so you just run it, just few lines of a code, 95%, that is not important, but important was that how you just come up with this decision tree, okay. And there confusion matrix, that how you read it, that is more important, because ultimately this is a type 1 and type 2 error, this diagonal, right? So which one to address, type 1 or type 2, because in many organizations type 2 error is very much critical. In some of the the medical domain, type 1 error is critical, right? So that you have to see that depending on the domain which one is critical, and we're trying to solve it. We just want to minimize both 47 and 49, right? Now we are just training this random forest. The same coding is same, but you will see there is a word called ensemble. Why it is ensemble? Because they are adding the different decision tree together. That is called an ensemble technique. So before I just run this, let me run it, okay, so that you'll have an idea. So I'm just running a random forest. I mean, because data set is your same data. So this is training a data, this random forest classifier. This is a random forest classifier. You're just training, and you're passing the training and this training data to the model, right? Because GT model 1 has a random forest classifier, and we are passing it the entire training data. Now it has trained, and then there is some visualization and something, okay. But important is this one. Just see, okay, whether it has changed or not, that I have to see. 47 and 49, there is some issue. Okay, let me check if 49 and okay, you'll see here, okay, there is a 51 was there, okay, but when you applied this decision tree, it has gone to 49, okay. So this means decision tree, their accuracy would be much higher, because this is a small data set, so it may fluctuate, but they have reduced to 49. Earlier it was, if you see this one, 51 and 44 was there. Now it has reduced to 44 to 17, and it has reduced to 49, okay. It means our work is to reduce this kind of a error, right? Because you are trying to find out the people who are defaulter can easily be captured earlier, right? That these are the people who will default in future, right? So this is more of a forecasting techniques through this random forest only, that these many people will default in near future. So you are trying to catch those people earlier, right? So that is why you are using decision tree, because in random forest, because in decision tree captures those non-linear behavior, that is fine. But on top of it, we are adding all those decision tree and making a tree, right? That is called a random forest, because random forest will have a more the refinement of learning these non-linear decision surfaces. That is more important. That is why I'm just showing you that it has reduced those type 1 and type 2 error. Earlier it was 51, 9 it is 49. It was 25, now it is 17. Okay, that is why through this random forest we are able to solve those type 1 and type 2 error. Okay, so now coming to, hope you have run this, and just run it once so that you'll have an idea. And if you see this one, there is something called underfitting. Obviously underfitting means obviously they learn a few patterns only, and okay, so maybe they are less accurate on training data, but on test data they have a higher performance. That is a possible. And underfitted model has some inherent bias, and you'll get to know that these are, both models are biased. And as I already told you, when it is underfitted, it means they will learn only the fewer patterns. Okay, only the fewer patterns they will not learn. I mean, they will learn. But in overfitting, they learn many patterns, but they memorize it. That is also a problem. In underfitting, they only learn a few patterns, that what they will learn on unseen data. They will not learn anything new, right? So the both are a problematic for a machine learning algorithm, this underfitting and overfitting. But when it comes to decision tree, so this kind of thing you will face. Okay. Now, if you go with this random forest, because that I just want to bring in, because this random forest is more important, and because it's a collection of all the decision tree, or maybe multiple decision tree together. So that is your random forest. Because when you say a random forest, and it's a more of a in a random manner. Okay, so let's say you have trained 5 decision tree, and now you are just aggregating the predictions of all those 5 decision tree together. So that will form some kind of a random forest. And random forest is an ensemble technique. It's not like a single algorithm you train on a single data set. You may use different classification machine learning algorithm, for example, for the same data. For example, a lone data set. If you have a lone data set, whether people have defaulted or not, let's say. So in that case, you may use decision tree support vector machine, k nearest neighbor, naive Bayes, bagging, boosting techniques, 5 6 algorithms, and you aggregate the predictions. So once you aggregate it, that is called ensemble learning, because you are aggregating the output of different machine learning algorithms, and then on that you pass this unseen data. So that is something you can think of a random forest. It's a collection of different trees together is a random forest. Okay, so there are a few concepts in this random forest. So you'll see this wisdom of crowd. Ensemble method is something which is more important, and there are many research paper around this ensemble techniques. So and still it is relevant, because in ChatGPT or something there are a few concepts which are embedded in it, this ensemble method, and the bagging boosting techniques are there. So you'll see in context of this random forest that how this wisdom of crowd works, and ensemble and bagging and boosting works. So we'll try to see that. Okay, for example, as I already explained you that when it comes to wisdom of crowd, for example, in a political party or maybe election of any country, so how it typically happens. So there are different campaigners or different leaders, and you just cast your vote, right? So it's like each and every person has a different liking and disliking for the party, right? And then you just cast your vote, and it's like aggregation of the peoples who have voted for a particular party gonna win, right? So I mean, it's more of a aggregation, it's more of a wisdom of a crowd, right? So what is the wisdom of a crowd, right? So it's more of a voting, right? So I mean, the aggregation of those answers. So similar way when it comes to ensemble learning, right? So there, if you see, there are different algorithms. Decision tree is one of the algorithms. On a same dataset you are training, and you are just saving their result. Same is naive Bayes, k nearest neighbor, and support vector machine. So on a similar data, single data, you are training 4 models, and then you are passing unseen data to the aggregation of this. Okay, and then you see the result. What you result, you see the prediction. So the beauty of ensemble is that it captures both linearity and non-linearity. If you see the support vector machines, it captures both linearity and non-linear decision surfaces also. Naive Bayes both. Okay, and decision tree obviously it captures non-linear decision surfaces, because your data set has a more randomness. To capture those randomness, you must bring in both kind of a classifier. One is linear classifier, other is non-linear classifier, so that even if there are a non-linear decision boundary, your model is able to pick up those hidden patterns. If your data has a linear patterns, your model is able to pick up those patterns. So the learning of both this, it's more of a left and right combination. So if you see in cricket, they try to bring people who are lefty and righty, right? Because they can play both kind of a balls. The same thing happens here, just trying to capture the non-linear as well as the linear decision surfaces on a training data set. So once unseen data comes in, even if they have a non-linear behavior or a linear behavior, your model accuracy will be much higher and your business problem will be solved. So this is how your this wisdom of a crowd, or you can say the ensemble learning, typically works, right? So there are two terms, bagging and boosting. Okay, so in coming class also you'll see in detail that how this bagging and boosting works. But when it comes to bagging, the concept wise, so create multiple data set through the random sampling with replacement. Okay, so D1 is one data set, D2, it was a let's say this is an entire zone data set, and you have just created a random data. Okay, and then you just build multiple learner parallelly. For example, in this data 1, you have just trained, let's say, a decision tree. In data D2, you have just trained a support vector machine. In this let's say naive Bayes and KNN, something like that, and combine all learners using averaging or majority voting. This is called a bagging. But when it comes to boosting, what you typically do, create multiple data set through random sampling with replacement over weighted data. There is some weights element added to it, and then we sequentially learn. For example, sequentially you apply some kind of, let's say, decision tree, random forest, naive Bayes, k nearest neighbor or something, and then you combine all data with weighted manner. So all the boosting algorithm, because they have some kind of a weighted average or weighted you can say some kind of a coefficients, weights are attached. That is why you will see the bagging and boosting, their answers are different, their predictions are different, because the boosting will algorithm will always be on a higher side, their accuracy will be much higher. Why? Because they use some kind of a weights. So whenever you see the weights are assigned, that model or that, even if in the you remember that in time series analysis there was also weighted average, right? So the weighted average, their answers were much better, right? So the same case here, the bagging and boosting, the logics are similar, but the boosting applies these weighted concepts. That is why their accuracy is much higher, right? So we'll see few more concepts also here. So, for example, you have a single data set, and how this ensemble techniques typically work. So, you are just trying to train different decision tree. Let's say in a few data points, you are training this decision tree 1, 2, and 3, and saving the result of all. Okay, and then averaging the result, and you'll see the final result. So, this is more of a ensemble techniques, or kind of a decision tree way of coming up with this random forest, because it's a collection of a tree. You'll see this is a 1 tree, 2, 3. So this entire process will come under random forest, because it works under the majority voting or averaging. Your result is being averaged using the different output which are coming from the different decision tree, right? So this is how your random forest works, and that is why they also learn the both linear and non-linear patterns. But when it comes to non-linearity, when your data set has a huge randomness, so go with this decision tree or random forest, because they're gonna capture those non-linear decision surfaces as well. Okay, so the ensemble techniques, which I have already explained to you. So this is your data set, and there are a way of bootstrapping it, like a replacement, and without being replacement. For example, you have a data set, let's say the training data set, we have 4 features, x1, x2, x3, and x4 is the feature, and y is a target variable. Okay, so someone is will default, 2 will not default, or something like that. Okay, and bootstrapping, in this data set we are just using x1, x3, and x4, and we are training on logistic regression. In this data set you are training on decision tree. In this data set you are training on support vector machine, and we are adding all those answers and coming up with one decisions. So this is one way of ensemble techniques. The same is written here. This is majority voting or more of a random forest. So whenever you see some kind of ensemble techniques, it means they are talking about the majority voting. They are talking about something averaging. They are going to average something. So ensemble is like aggregation of different trees together. Okay, so this is the same thing. And when it comes to this this ensemble, so I mean the bootstrapped sample was there with a replacement and without replacement, and training this algorithm. So predictions 1, 2, 3, 4, 5, these things are there. So, and you will see the final predictions at the end. So this is how your data set, if you have if you want to apply this ensemble techniques, and your data set is more random and has non-linear behavior, then you have to go with this bagging boosting techniques, random forest techniques, a tree based technique. At least you start with a tree based technique, that is a decision tree, then random forest, and other the boosting techniques are there, and then you come up with final predictions. Okay, so this is how this is just visuals of majority voting, averaging things, and then coming up with this class. Okay, so for example, this is your entire data set, and this data set, once you on unseen data, is saying that there is a one apple there. So through this decision tree you come up with the class A. And also once you on this support vector machine, let's say using this training data set, your model is saying this is a apple only. But once you train on, let's say, logistic regression, they are saying in this there is a apple, there is a banana, right? But once you average it out, you'll see only this class, right? So the beauty of using this ensemble technique is that the two model is telling you that it's apple in this bucket, but one model is saying there is one banana. So you have to go with this majority voting wisdom of crowd. This is what ensemble techniques typically works, right? So how are you gonna decide that? How are you gonna differentiate between decision tree and random forest? Because both are tree model and both understand this non-linear decision surfaces, and they are both incorporated. So why you should use random forest or decision tree at first place? So obviously, let me go with this. This one from the bottom, right? So decision tree is simple and easier to understand and interpret and visualize. Okay, so obviously the interpretability part is much higher. So obviously, if you have some business case, let's say, and you have been asked to come up with a model who are which are self-interpretable, and that can be easily explained to the end users or maybe the client, right? So obviously you'll take help of this decision tree because they want interpretable model. But obviously uh, random forest is complex because you are adding a different decision tree, maybe multiple decision tree together, right? So but the result in terms of accuracy, you'll see the random forest has a higher accuracy, but here it's less because you are adding, there is average voting here. That is why they are more accurate, and reduced risks of overfitting because you are adding multiple decision tree. That is why overfitting is being removed, because your model will not learn training data set. They will understand few also a new pattern, right? So that is a randomness, and these are just a definition. So you have to understand that when to use decision tree and when to use random forest, and what makes decision tree to be different from random forest, and what makes random forest to be different from decision tree. That both are tree model, right? But when to use which model is depending on the nature of a business problem, whether you want a more interpretable or you are hitting the accuracy part. If you want more accuracy, then go with the random forest. Okay, so the bagging and this random forest. So we'll see that the accuracy part, it improves the accuracy and the stability of machine learning model using the ensemble learning. The random forest algorithm is very robust against overfitting, and it's good when unbalanced and missing data. So you have to see the business case first. So let's say you have unbalanced data. Unbalanced means, the labels are unbalanced. For example, purchasing and not purchasing. So 80% are not purchasing and 20% are purchasing, and you have been asked to train the model. So obviously it will be biased. So in that case, if your model is so biased, so you have to go with this random forest. But bagging is also one of the best approach, because they use this ensemble technique and wisdom of a crowd, voting and everything. And bagging, also use this the ensemble. But when it comes to boosting, they use this weighted average. So obviously, you have to see depending on the use case, because each and every algorithm can be used for a classification, but you have to be more specific that which business case you are solving. That is more important. Whether you want model to reduce this biasness, because if your model is biased, so obviously the prediction accuracy will be lower. So you have to see few things. If your data is, let's say, a random, there is a non-linear features, there are more randomness, your classes are unbalanced, the values are missing. So in that case, you have to go with this random forest. Okay, so you have to see that which algorithm to be used. Okay, so this is all for today, and maybe if you have any questions, you can ask, and otherwise we will wrap up for today, and we'll see in the next class, and also I'll upload it. Okay, so if you have any questions, you can ask. Okay, so if you have any questions, then you can ask. Otherwise, I'll wind up today's session. Okay, so Dipti, just take a screenshot of the class. Okay,
Okay, sir.
and I'll upload it, and if you feel like I'll also upload few